Welcome back, everyone. We're going to be solving LeetCode 113, path sum 2. So we're given the root of a binary tree and an integer target sum. We need to return all root to leaf paths where the sum of the node values in the path is equal to the target sum. Each path should be returned as a list of node values, not node references. And they define a root to leaf path as a path starting from the root and ending at any leaf node where a leaf node has no children. So if we take a look at example 1, we can see there are two paths from the root all the way down to a leaf node, right, which equal the target sum of 22. So we are going to solve this with a depth first search. What we're going to do is search every path through here. Whenever we come across a leaf node, we're going to check, does the sum of the path equal our target sum? If it does, we're just going to take the path and append it to an output variable, right? Easy enough. So we will have a stack. We will have, on this stack, we will have the root. We will have an initial visited status of false, and we will have a path which will initially start with the root.val. We will also have an output array. Now all we have to do is just run depth first search. So we'll say while the length of our stack is not equal to 0, we are going to grab the node, the visited status, and the path with stack.pop. Now, first thing we're going to do is check if the node is not none. What are we going to do? Well, now we have to check, have we visited this node before? So if visited is equal to true, meaning we have visited it before, then we want to check and see if we're at a leaf node. We can do that by saying if node.right is none and node.left is none. If that is true, then we have to check, all right, well, does the path sum of the current path equal the target sum? So we'll say if the sum of the current path is equal to our target sum, then we are going to say res.append the path variable, right? Super easy. Now, let's fix this visited spelling. Now we can say, all right, we are going to do a pre-order traversal. So we will say stack.append the current working node with a change the visited status to true and just append the path. And then we want to check the right and left sides. So we'll say if node.right is not none, what are we going to do? We are going to say stack.append the node.right child along with an initial visited status of false along with an updated path variable. This path variable is going to be the original or the current path that we're at plus the node.right.val, right? We're just adding that onto our path. Now we can do the same for the left child. So if node.left is not none, we can say stack.append node.left visited status false and update the path with the node.left value. And then at the end of all this, we can just return a resulting array. So let's go ahead and run this. Perfect, we pass all 3 test cases, so we'll submit. And none type object has no, I missed the base case. So if we're given a tree or an empty array, right, so if not root, we should just return an empty array. So now this should work. Yep, and it does, perfect. So time and space complexity of this is going to be O of n for time, and the space complexity is going to be O of h, where h is the height of the tree, or in other words, the length of the stack, right? The stack can grow to the height of our tree. All right, that'll do it for LeetCode 113.